Okay, so let's continue our review of the process of the insertion sort. And for this part, let's go through the code line by line. And say we start from the very first line, and then this is the unsorted list, and we are going to start from the I equals 2, right? Because the number 1, the first value that is already sorted, if we consider it as the only value in the sorted portion. So the first thing we want to do is we want to expand the sorted portion to the first 2 items. So we want to include the value 10. So the first step, we have the I as 2 and j is 1, and then, well, the key is 10 because this 10 is the value we want to insert into the right location in the sorted portion. And after that, we have to check this condition, line 4. So for each value we want to insert into the sorted portion, line 4 is guaranteed to be executed for at least once. And how about the line 5 and line 6? They might be executed or not depending on whether the new value is at the right place. Okay, so for this case, we do have to execute the line 5 and line 6, so we are shifting the 30 to the right side, and eventually we want to insert the key to the first place, so we have the 10 and 30 as the sorted portion. Okay, and then we include the 30, we include 40. So when we include the 40, and then we want to check the line 4 again. So we check the line 4 once, but the line 4 will give us a false. So we check line 4, but we don't have to go into the iteration to run line 5 and line 6. So that's the difference. So line 4 is guaranteed to run at least once. But if the condition in line 4 is false, we ain't gonna run line 5 and line 6. Okay, so in this case, line 5 and line 6, they're gonna be skipped. However, well, we still have to do insertion. Well, it's weird, right? So, well, even though 40 is already at the right place, but we are inserting 40 into the same place again. Well, this is how the implementation is done. So we don't really check whether j plus 1 is exactly the same as I or not. We don't check that. But eventually, after finishing the iteration from line 4 to line 6, we just insert the key into that location. Well, in some cases, if the new value to be incorporated into the sorted portion is already at the right place, it doesn't matter, we still do an insertion. Okay, so and then eventually we want to do the 20, and for the 20 we do have to check the condition, the line 4, and then we do have to shift what values onto the right side, and then eventually we do the insertion. So okay, so this is the process. And now let's do a serious discussion about the time complexity or the cost, the effort to do the insertion sort. Okay, so let's ignore the effort on the right side for now. And then if we try to do a high level of the review, and remember, we started from the first value already considered to be in the sorted portion. So we only have to include the rest n-1 values into the sorted portion, because we started from having the first value already in the sorted portion. Okay, so we are doing how many insertions? We are doing n-1 insertions, not n insertions. So that is the one thing we want to remember. Okay, and then for the inner iteration from line 4 to line 6, well, for each value to be inserted, it's guaranteed we will run line 4 once. Line 4 is going to be executed at least once for each of the value to be inserted. However, for line 5 to line 6, we don't know. Well, in the lucky case or in the best case, and then the condition of the line 4 is a false, and then we don't have to run line 5 and line 6. But usually, in the average case at least, we are going to run line 5 and line 6 for some number of times. Right? Okay, so this is a high level understanding of the insertion, and then we assume that for each line of the code, well, they are all primitive steps, and then for each line of the code we assume there is a cost or a time to execute that line. And the cost will be C1, C2, all the way to C7 for each line of the code to be executed. Okay, and then, well, we have to count how many times do we have to run each line of the code. Okay, so for the line 1, the cost is C1, and then how many times you're going to run the code? n-1. Why it is n-1? Because we are inserting n-1 values into the sorted portion. So it's guaranteed line 1 will run for n-1 times, and the same thing for line 2, line 3, and line 7 as well. So why line 7 is going to be executed for n-1 times? Remember, for each of the value to be inserted to the sorted portion, it doesn't matter where we are going to insert that, we are going to do the insertion. So line 1, line 2, line 3, and line 7, they are going to be executed once for every value to be inserted into the sorted portion. Okay, so far so good. Okay, and line 4, 5, and 6, they are the tricky part. Okay, so we are going to introduce a new value to help us as a bridge to solve this problem, and we assume that is t. So for the t, that is the t2, t3 to tn, well, where ti is the number of how many times that the value expression is evaluated. Okay, so well, to insert each of the value, we may have to execute the line 4 at least once, maybe many times, and then we just add how many times we are going to execute the line 4 for all the values from the second value to the last value together, and that is the uppercase t. Okay, and then, well, if line 4 is executed for t times, and then how many times do line 5 and line 6 executed? So it should be t minus n-1. Why? Because, well, if for one value, to insert that into the right place, line 4 is executed for k times, and then how many times are line 5 and line 6 executed? This should be k minus 1. Why? Because for k times, the line 4 is executed. This means the last time we executed line 4, this condition will give us a false. So we process or we visit the line 4 for k times. The last round, it will be a false. And then the k minus 1 rounds, they are all true. And then for those k minus 1 rounds, line 5, 6 will be executed. Okay, so the difference of that number of the executions between line 4 and line 5 is always 1 for each of the values to be inserted. And how many values are we inserting? The number should be n minus 1. Right? So that means the cost of running the line 4 should be C4T. And then for the cost of running line 5 and line 6 should be C5 T minus n minus 1 and C6 T minus n minus 1. Okay, so we figured out the effort to run the whole algorithm by counting how many times we are gonna visit each line of the code. Okay, so for the effort on the right side, I want to add them all together, and then I have this. So I add that all together, and then I'm gonna use the notation Tn. So this means the time or the total effort we are gonna spend to sort n values using the insertion sort. So we put them together, and guess what? For C1, C2, C3, we don't really worry about them too much because they are just constant values, and then they are not going to change. I don't know C1 is greater than C2 or slightly smaller than C2, it doesn't really matter because they are constant values. So how about I just turn them, I just massage this and then put them into this case. So what is C8? Well, C8 is a constant value. Well, it could be the sum of C1, C2, C3. I don't want to know. But, well, the Tn will be in this form. So a constant 8, T, plus a constant 9, N, and plus the constant 10. Okay? So this is a polynomial of the T and N. So what is T again? So the T, in the best case, the T is what? The T is the T means we only T is the sum of how many times we process line 4. And in the best case, for each value to be inserted, we only touch line 4 once, right? So in the best case, what is T? T is n minus 1. So that is a linear function to n. You get that? Okay, and how about the worst case? The worst case is, well, for each time we are gonna insert a new value, we have to shift, well, all the values in the sorted portion to the right side. So we begin from shifting one value. The next round we shift two values. Say here. So when we insert 5, we have to shift 6. So in the first round we shift one value. And then when we insert 3, we have to shift 6 and 5. So 3 goes here. So we have to shift two values. And the next round, we want to insert 1. So 1 comes here. And then we have shift 6, 5, and 3. So we have to shift 3 values to insert 1. So that is the sum of 1 plus 2 plus 3 plus plus n minus 1. And what's the sum of that? That is n squared minus n, and then put them together divided by 2. So what's that? That is a quadratic function to n. So that's the difference, right? So in the best case, Tn is a linear function to n of n, and then in the worst case, Tn is a quadratic function to n. So that makes a difference. And what's the average case? So for the average case, well, we ain't gonna be that lucky, so it can't be linear. And then we are gonna shifting some of the value, but probably not that many. So in the average case, so how about we assume that on the average case, instead of shifting all the sorted portion to the right side, at least we are gonna shift half of the sorted portion to the right side. So in this case, it is still quadratic. Okay? So, well, let's do a little more analysis, but, well, this video is long enough, so let's finish this slide and then I will stop. So we are going to do some simplification. So, well, usually we want to ignore the sum of the statement cost of some of them, and then well, when we are interested in the order of growth. So if we only have 100 value to sort, well, we don't do this. We don't do the timer. Well, but we are interested in this question. If we double the input, are we gonna double the time? Or the running time doesn't change at all? So, or the running time is worse than doubled because the time complexity of the algorithm is high. Okay, so we are not worrying about the time to execute a input size if the input size is fixed. We are interested in when the input size increases, how does the running time also increase? Okay, so I think this video is long enough and I want to stop here. And well, so far we got this. So we are trying to get the Tn, that is the total time to execute the entire algorithm, and we want to figure out the Tn to be a polynomial of n, where n is the input size. So this is how far we have got. Okay, so I'm going to pause this video and let's continue in the next one.